Yeah, welcome to my YouTube channel. In this video, I will be discussing on one of the key exchange technique we are using in symmetric key cryptography known as Diffie-Hellman key exchange. Okay, so here we will see some key concepts on Diffie-Hellman key exchange. Next, we will see the working of Diffie-Hellman concept, and lastly, we will see one example how we need to calculate the secret key that is shared between two parties using Diffie-Hellman key exchange concept. So here is the basic concept first. Diffie-Hellman is a key exchange protocol, as I told. It is not an encryption technique, it is a key exchange technique that allows two parties to agree on a shared secret key over a insecure channel. So our duty is to calculate the secret key that is shared between two entities. After calculating that key and after sharing, then further you can use the same key for encryption. That is what? To encrypt the data. Okay. This Diffie-Hellman key exchange technique was proposed in 1976 by Whitfield Diffie and Martin Hellman. These are the two people who introduced this key exchange technique in 1976. Okay. So why do we need this Diffie-Hellman key exchange? We know already that symmetric encryption is fast and secure when compared to asymmetric encryption. But the only thing is, in symmetric encryption, both the parties, means both the entities, should share the secret key before they are going for encryption. But sharing of the key itself is somewhat challenging. If the key is leaked or if it is stolen by some third person, then you can easily decrypt your data. So this Diffie-Hellman solves that problem of distributing the key securely without any prior shared secret. So easily you can calculate one secret key that can be shared between two entities, and you can use that key for encryption in symmetric cryptography. Okay. Now let us see the working of Diffie-Hellman key exchange technique. It is very simple. We have only three steps. First we need to assume some global parameters. Then calculation of private and secret keys for, private and public keys for user A, that is first user and the second user, and lastly generating the secret key by both the parties. First, assuming global public entities. So two things we need to assume. One is known as prime number, any prime number. I will name it as Q. The other one is some alpha. Please keep in mind that alpha should be less than this prime number Q and it should be relative prime to Q. So how to find the primitive prime root to Q? So how to find this primitive root? I have already done one video. You can watch my previous video how to find the primitive root of any value. So once we got these two values, Q and alpha, Q is nothing but prime number and alpha is nothing but primitive root of this Q. Then, as I told you, two users are there, user A and user B. Then user A should calculate the private key and public key. Private key should be assumed by him and he will calculate the public key. Okay. So now you can see here, first the user A will select one private key, any key, that is secret. Okay. That I will name it as XA. X is known as secret key. A is nothing but user A. Please keep in mind the any value that you are assuming, that is X of A, should be less than this prime number Q. Okay. Then he will calculate the public key, which is nothing but Y of A. Please keep in mind X is nothing but private key and Y is nothing but public key. So how he will calculate this public key? He will calculate with the help of this private key. So this is the formula to calculate y of a is nothing but alpha power x of a mod q. We know already alpha, that is nothing but a primitive root. X of a is known as your private key. Mod q is known as your prime number. So once you've done, you got y of a. So here x of a is nothing but private key of user a, and y of a is nothing but public key of user a. So once he calculated this y of a here, I am sharing that user a will share that public key to user b. Okay. Similarly, user b also will do the same thing. Okay. Here user b is calculating the public key. First you will assume the private key. You will name it as xb, and you will calculate the public key, nothing but yb, which is nothing but alpha power, okay, xb mod q. Then you will get public key of user b. So once he calculates this yb, he will share that public key to user a. That is what we call it as mutual sharing. Public key of user a shared to user b, and public key of user b shared to user a. Now user a contains 3 keys. If I am not wrong, he is having the private key of user a, public key of user a, and also he is having the public key of user b, which is shared. Okay. Similarly, user b is having 3 keys. Which are those? Private key of user b, that is what he has assumed here. Public key of user b, that is what he has calculated here. And also a public key of user a, that is shared here. Okay. Now using these 3 keys by user a and these 3 keys by user e, they will calculate what is known as secret key. That is the final step. So how you will calculate the, so for example, user a will calculate the secret key, that is k, using this formula yb power x power a mod q. Here yb is nothing but what? Secret, that is public key of user b, that is having here. X of a is nothing but secret key of user a, that is having here, and mod q. So then you will get some value. Similarly, user b will also calculate the shared secret key k, y power a, which is nothing but private key of user a, xb, which is nothing but private key of user b mod q, that is y power a power x power b mod q. Then you will get one key. Please keep in mind this key and this key both will be same. That is what we call it as secret shared key. So this key will be used for further for encryption process by the symmetric key cryptography. This is how the secret key will be generated by both user A and user B, which is common. Please keep in mind the key that is getting here is both are common. Okay. Once that key is generated, that key can be used for symmetric key encryption. So in this way, the Diffie-Hellman key exchange will work. Hope so understood. Now let us see one small example how to calculate this K, that is what secret key, by both sender and receiver, or user A and user B. So this is one small example. So here we need to assume Q, no? So I am assuming Q as 23, one prime number, and alpha I am assuming 5. So how we got this 5? That is nothing but a primitive root of Q. And here the private key of user A, XA, okay, is nothing but 6, and the private key of user B, XB, is 15. Now determine the public key, that is XB and YB, for both user A and user B using Diffie-Hellman key exchange algorithm. See here, the given values are Q 23 and also alpha 5. So what is our first step? We need to calculate the public keys first. Okay. So calculate public key of user A, nothing but XA. How to calculate? Sorry, not to calculate, because private key already they have given X of A, nothing but 6. So now we will calculate the public key of user A, nothing but Y of A. So what is the formula? alpha power x of a mod q. Alpha is nothing but 5. Okay. X of a, that is private key of user a, is nothing but 6. 5 power 6 mod 23, which is nothing but q. How much you got? 8. So this is nothing but y of a. Public key of user a, that is shared to user b. Similarly, calculate public key of user b with the help of private key of user b, which is given 15. So the formula is y of b is nothing but x alpha power xp mod q. 5 power 15 mod 23, which is nothing but 19. This is nothing but yb. So this is shared to user a. Now lastly, we need to calculate the shared secret key. So calculate the secret key by user a. How to calculate? This is a formula. Okay. Y power b power x power a mod q. Y power b is nothing but, okay, this one 19, which we calculated here. And x power a is nothing but secret key of user a, which is 6, that is given mod 23, that is nothing but q. You got what? 2. Now calculate the secret key of user b. So now k is nothing but y power a power x power b mod q is the formula. Y power a is nothing but what they have given 6. Sorry, not 6. Y power a is nothing but how much? Which we calculated 8. And x power b, what they have given 15. Mod q is nothing but 20. You got C. If you see, both are common. That's what I told here. This value what you are calculating and this value what you are calculating, both are same. That is what we got as shared secret key. So what we got? 2. So this 2 can be used further for symmetric key encryption. So hope so you understood now. So let's, and where exactly we are using this Diffie Hellman? So we are mainly using this in establishing keys in TLS as well as SSL in HTTP requests, like request and reply concept. We are using in secure shell encryption techniques, and also we are using in VPNs, virtual private networks, using IP security protocol. So here is a small assignment for you. Using Diffie Hellman key exchange techniques, find the A's public key as well as B's public key, that is y of A and y of B. The given values are kv equal to 71, alpha is 7, and the private key of user A is 5, and the private key of user B is 12. Now you need to calculate xp, and you also should calculate yb. Okay. Then you need to calculate shared secret key k by user A as well as user B. After that, you try to draw an algorithm, flowchart, and also write one C++ program to implement Diffie Hellman key exchange algorithm. So you can put this complete assignment in the chat box. Okay. Hope so enjoyed the video. Thanks for watching, and subscribe my YouTube channel for more videos. Bye.